Hello and welcome back, everybody. When I last left you, I had just finished assembling the caster wheel in Autodesk Inventor's assembly type file. Now we're going to create a drawing file to go along with this. So to get started, we're going to click File, New, and make sure we're in metric and select ANSI mm.idw. So a review again. .idw stands for drawing file type. We're going to hit create and we're going to load up a D-size sheet by default. Now, this is perfect for us because this is a large drawing sheet, but it has a lot of space and we're going to need all of it for our caster. We have a lot that we have to put into this border. So we're going to start by placing the base view into the D-size sheet. So we're going to start by making sure our caster is open, which it is, and we're going to select base view. Now this brings mine in to the sheet as the front view. So the view that looks at the retaining clip in object detail, this is the view that you need to bring in. So when you're going to place your caster in and you don't see this, just make sure you play with the cube here until you get that view, right? So in my case, mine is the front view. It's already aligned up perfectly the way I want it. So again, if you don't see that, you can just adjust your cube here and you can find it. So once you've done that, make sure hidden details here under style or hidden line is switched on because we want to see the hidden details or hidden lines inside that view. So once you've done that, and scale should be 1:1, we hit OK. All right, and this is what it looks like. So it looks like everything looks the way it needs to be. This hidden line here represents my keyway, and then this one represents my rib. It is perfectly aligned in the assembly. Everything looks great. So what we're going to do next is we're going to create a right-hand sectional view. So to do this, we're going to go up to Section in Place Views. And I'm going to bring my cursor in. And when I bring my cursor close to the assembly, I get this red broken rectangle that kind of borders that view. So I'm going to want to click into that once. That's going to get me ready to create my section. And I'm going to bring my cursor to find this midpoint here. When I see that snap appear, that green snap, I'm not going to click on it. Don't click right on top of the post, but when you see that, move your cursor up and you'll see that trailing dotted line. So somewhere around here, left click, and then start to draw your cutting line. So you're going to come through the post and you're going to stop somewhere after the post and before you get to the most top quadrant of the wheel. So you're going to want to start around here and then come over to the left and then come down and touch to find that quadrant snap. And then once you find it, Inventor will want to project the dotted line downward. So once you see that dotted line, you can left click again. You should also see the parallel symbol come up as well. And come down. So we're going to cut right through the middle of this. And we're going to leave a little more room like where we began. We're going to try to duplicate that as best we can, create a little more space. And then left click. You'll see the parallel symbol become active, right click, and then left click continue. And this is going to create that right-hand sectional view. And we'll drop it, I guess, right around here. So we'll left click, and that's going to create your view. So this is how it should look. It should be orthographically aligned with the front view of the caster assembly. Now when we take a look at this, let's zoom in and inspect it. Everything looks correct. So we have our bushing inserted into our wheel. We have our shaft sitting inside the bushing with a little bit of clearance on each side. We also see that retaining clip attached to that groove diameter, which keeps this shaft from popping out. We have our bracket and we have our post up here. So everything looks great. The only thing I don't like about this is that these section lines, I would adjust these section lines to change their angles a bit. So when we look at this, for example, our post here, we'll start here. That should be an angle of 45 degrees, which it is. All right, so we're going to leave that one alone. So we're going to say OK. The bracket, it should be 135 degrees. Now it's a little off, so I would just fix that. I would just make that 135 even, hit OK. Barely going to notice it. Oh well. This one here should be set to 45. Let's fix that one. That one's not so subtle. So that's our shaft. This is our bushing. We're going to change this one to be 135 degrees. So we want it to go the opposite way. And we want our wheel to be 45 degrees. So the idea here is every time a sectional view of an item is up against another item, that section line needs to be reversed. It needs to be a hard 45-degree reverse. Now the reason for this is so we're not confusing this to be all one item, right? Basically, we have 6 items we're showing in our sectional view, and this allows the person in the shop, when they read the drawing, to see, yes, the post is one item, and the bracket is one item, and so on. Now, you may think, well, obviously he knows this because he's trained in reading drawings. Well, yes, he is, or yes, she is, but we have to show things properly, right? There's a standard to creating technical drawings, and we have to follow those standards. So next up, on an assembly view, it's typical to show one dimension, and that one dimension should show an indication of overall size in height in this case. So what we're going to do is go to Annotate tab, select Dimension, and we're going to go up and we're going to select the top line of the post, and this dimension can be a little difficult to snap, so what we're going to do is we're going to begin by snapping it to the center of the wheel, and we're going to pull the dimension out. Remember what I said about dimensioning in Inventor? You just don't want to drop the dimension anywhere. You want to pull it out off the part and see what the broken line gives you. So this is way too close, right? This is not bad. It's a little close. I would come out to here, right? To me, this looks like the equivalent of about 12 millimeters from the wheel by eyeballing it. And I'm going to drop that dimension and create it, hit OK. And I'm going to want to escape dimensioning and right click, left click, OK. Now what I need to do, I want an overall height. I don't want from the top of the post to the center of the wheel. I'm going to grab the extension snap on the extension line, and I'm going to pull it down and snap it to the bottom of the wheel. That's going to automatically center this dimension for me to show 147. Now we're trailing 2 decimal places here. Not required, right? We don't have decimal places on our millimeter values on the iPad sheet we work from the hub with. So what we're going to do is double click, go down and left click edit dimension, and we're going to go to precision under units, and we're going to take this to 0, and then hit save and close, and that's all we need, right? So that is good enough for us. I mean, a millimeter is fine enough. Why add decimals to it? Unless we were showing basically a half millimeter, which we'll talk about later on in another lesson. So next up is to create the parts list. We're going to throw the parts list up into the top right-hand corner. So to do this, we're in annotate, we're going to select parts list, and we have to select a view to get this started. So what we're going to do is we're just going to come in here, we're going to touch inside that broken red dotted square rectangle, and then we can hit OK, and then that's going to create our list. So we're going to pop this list into the top right hand corner. And if you look at this, because of how the 3D assembly was created, we're ascending in proper order. Item 1 is the post. Item 2 is the bracket. Item 3 is the shaft. Item 4 is the wheel. Item 5 is the bushing. And item 6 is the external series retaining clip. Metric series. Perfect. All right. Now, I'm not totally happy with this parts list. I want to be able to list the item number and the quantity first, which is already here, but we want to edit the part number away, and we want basically part number to act as description. So we want material to be posted up here. So we're going to double click this list, and this is going to allow us to edit this. So we're going to go to column chooser, select it, and this is what we have loaded so far. So we're going to select part number, and we're going to select remove. And then in this list on the left, find material and then hit add. But I want this to go item quantity material description, not the way it's shown here. So material is selected. We're going to hit the move up button. That's going to put it where it needs to be, and then we're going to hit OK. So that forces material to be generic, which is not what we want. But we'll come back and we'll fix that. So we know that item 1 is the post. So let's type that in. Item 2 is the bracket. Item 3 is the shaft. Item 4 is the wheel. And item 5 is the bushing. So you have to update that. And material, we don't want generic. So the material for the post is SAE 1112. The material for the bracket, now this is a gauge material, so this was 2.38. Number, series, 13 gauge, capital G. SGA and the bracket. So what we're going to do is we're going to drag that over so it all fits on one line like that. Item number 3 is the same material as item number 1, SAE 1112. The wheel is made of a hard rubber. The bushing is made of brass. Now, this clip here. Now, it says that we're using, it doesn't actually give the numerical clip size, but according to the iPad image sheet I'm looking at, it shows it as a 5133. Now, I went through Inventor's Content Center. I could not find the clip that is asked for, so that's why I substituted it with the one that I had found. Now, I don't need this giant description for that. So basically what I'm going to do is just call it an external retaining ring series 5133. So I'm going to call it what it was on the sheet, the call out on the caster image from the hub. Now, in terms of material, I don't know what material that clip is made of, so I'm just going to go along with, I'm just going to use the same, I'm just going to use stock for that. Meaning that we're not, what that means is we're not actually making that clip. That clip is going to be ordered from a part supplier. So I don't need to worry about putting the material in because no one in the shop is manufacturing it. Of course, we do need to know what type of ring it is we're getting. That makes a lot of sense, but so we know what to order when we call, but again, it's a stock item, we don't care, right? We're only manufacturing items 1 through 5 in the shop. So we're going to hit apply and OK. And that's going to populate our parts list. What we can do is, again, we can just stretch this like that. We want to get it all onto one line. So we're just going to play with that a bit. Right, so that's how you should manipulate it. It looks a lot better like this. Okay, so we're going to leave that like that. And next, we're going to create the isometric view of the caster. We're going to tuck it under the parts list. So we're going to come back to here, click Create View and Projected View, and we're going to pull this up to here. And we're going to drop it, right-click, left-click Create, and there's our caster wheel assembly. Now it's customary to throw isometric views in the top right-hand corner. Depending on any software you're using, why not do this? It's a bonus for anybody who's building the part. They can get an isometric view of how it's supposed to look. And this is the best view to show because it shows our retaining clip in place as well. So we don't want to have the hidden details on for this. So don't have the hidden details on because it's going to look too distorted, right? This is basically just what we see in object line. So it's a little big, we could scale it a bit. We could just scale it to 3/4, and that's basically all we need, right? Because we don't want it to compete in size because we want all of the 2D formal orthographic views to be 1-to-1 scale, right? This is not to be used in terms of manufacturing. It's just for bonus. So we have that. Next, we're going to look at placing the balloons on here. So again, under Annotate tab, we're going to select Balloon from this list, and we're going to select all the pieces. Now, it's a good idea to try to keep these from being between the two views to prevent crowding, but I'm going to at least put one balloon here, and you'll see why. So I'm going to start with the post, item number 1. So I want to do this in ANSI format. So I'm going to select somewhere on the post, come up on an angle, left click, and then pull the balloon to the right, and then left click, right click, left click, continue, and that's going to finish it. Right? We want this to be consistent as well, right? I don't want balloons sticking way out here, or some shorter, some longer. We want them to kind of line up in the same linear vertical, imaginary line. So we're going to start with, we're going to do this second. So this was the bracket. So we're going to come over like this. We're going to come over and try to line it up. See how I can line that 2 up with the 1? I just want to straighten up my horizontal line on my leader. Left click, right click, left click, continue. Next, and this one's a little crooked. So we'll just do that. Straighten it up. And this one's crooked. Okay. Well, anyway, it might be just the way Inventor is in 2019. It's using a lot of memory. So balloon. We're going to select the shaft. and keep that 3 in line. That's the bell. Okay. Next, we have the bushing. So we can select the bushing here. Now, because this is butted right up against the wheel, I might do something a bit different. This leader, I don't want to mistake this leader for pointing to the wheel. So what I can do is just drag it up. And then it basically, it's no longer a leader, it's like a datum point. So basically there's no question that I'm actually identifying part 5 here as the bushing and not the wheel. Okay, and then we have 2 more to do. We're going to do the wheel, item 4. Keep that in line. And we have item 6. Now, I'm not going to run the 6 on this side and have the leader cross through the entire assembly. So I'm just going to run this one right on this side here. See if I can get a reference point there. And I can. Okay, because it's all about looks. Presentation is everything in a technical drawing. And if you've been with me since grade 10, you would really understand that. Let's just fix this if I can, because I'm picky. Okay. All right, that is it for the assembly and the parts list. We're going to look at might as well do the title block now, and then we're going to call it a day for this lesson, even though we're not finished with it. So to fill the title block in, we're going to go to File and select iProperties. We're going to go to Summary. The title of this is, in all caps, is Caster Assembly. And I'm also going to put plus details, because we're going to include all the detail drawings in this sheet as well. And the company, right, is our high school, Ancaster High. And project, okay, part number, this is our very first drawing in our course. So we use the last 3 digits of the course code, 4M1-01. And our revision number is 0, because this is an original release of this drawing. And I'm going to change my name to something a little more proper, right? I forgot to do this in author. So it's K period space Lemieux, right? That's how you should indicate your name on any drawing. First initial of your name, period space, last name. That is the professional way to identify yourself. Under status, we're going to also put on a checked by person. Now, the checked person is someone in the class who can check your work. You should have a drawing checker selected, and they will check your work before I check it. So in my case, I have a drawing checker, and his name is Mr. Valance in Student Services. So he likes to check my work. So I'm going to use him. And the date that the person checks the work, I mean, this doesn't have to be checked on exactly. I'm not really concerned about this. I just want to know who the checker is. But you can check that on if you want. So check date. It'll just come up with today's date, and then that could be edited if you want. So we'll hit apply, close, and this is all we really care about, right? So we have the scale listed, the drawing number, the sheet size is automatic, our title, the Rev 0 it's not revised, it's an original release. The high school we work at and learn at, who drew it and who's going to check it. This is quality assured manufacturing approval and approval and so on. So we're not going to worry about these ones. And that is it for now. We're not done with this yet, and I'm probably going to be moving this over to the right later, but that is how you get the drawing file started. So this is going to be your next activity in the caster project. We're getting near the end, and it's starting to look great. So good luck, take care, I know you'll do great things. Bye for now.